All right, this is lecture 5.3b, and we are going to continue to find inverse functions analytically and graphically. We're going to do analytically today. When we are finding an inverse function, there are steps that we need to take. Here are the 4 steps. You need to memorize this, okay? The first thing we need to do is we need to determine whether or not the function has an inverse function by checking the horizontal line test. And how do we do that? We draw a graph of it and we look to see if there is more than one location that the horizontal line crosses. If there is, then it will not have an inverse function. Step 2, in the equation for the f of x, we're going to replace f of x with y, and then we're going to switch the x and y. And you'll see what I mean by that in just a minute. We are then solving for y. So we develop our new equation, and that new equation, instead of having a y equals, that is actually the inverse of the original function. So that is the inverse of f of x. We will then have to evaluate the domain restrictions of that inverse function, which were originally the range restrictions of the f of x originally. All right, that's a lot. This is not easy, in my opinion. I will just say this is one of our harder lessons that we've had this year. So let's actually do this together. Here we go. F of x is equal to x cubed minus 10. The first thing I would do, or you need to do, is actually sketch what that x cubed minus 10 looks like. X cubed, if I have -2 and I cube it, I get -8, -1, I get -1, 0, 0, 1, 1, 2, 8. And so if I actually look at that and notice I have a shift downward 10, so somewhere this graph starts approximately at 0, comma, -10, and it will look something like this. And I'm really bad at drawing these. Let's see if I could do that again. It'll look something like this. There we go. Okay, so that is not the greatest graph, but nevertheless, that's what that sketch will look like. It has a domain. What are my x restrictions? It has none. It has all reals for all my domain, and my range also has all reals. Okay, so there's my domain and range of my original function. Okay, so now what do? I am going to replace that original f of x with a y, and then I'm going to start to develop my inverse function analytically, and I will switch the x's and y's. So I had originally y equals x cubed minus 10. Now I want you to switch. Wherever there is a y, I want you to put an x, and where there's an x, I want you to put a y. Now I need to solve for y. So I'm going to add 10 to both sides. So x plus 10 equals y cubed. I need to undo the cube. So I'm going to take the cubed root of both sides, and I will get y equals the cubed root of x plus 10. Now, that is, what did we just find? We just found an equation for y, but that's not y. That is actually the inverse function of x that we have just developed analytically, x plus 10. All right, so what does that look like if we were to graph? Well, we have a cubed root. We've just learned how to graph cubed roots, and it has x plus 10, so we actually are going to move over to the left 10. So that actual data point is at 0, -10, and a cubed root function looks something like this. Like, okay, let's see if I could do this. Didn't we do, yes, like that. Okay, there we go. And notice, it's a terrible graph because I'm really bad with cubed roots, but nevertheless, that is a reflection across the y equals x line. Now, it asks for any domain constraints on the inverse function. Okay, well, the range of my original function becomes my domain of my inverse function. And since my range had all reals, there are no domain restrictions on my new or my inverse function. Okay. All right, let's do another one. All right, B, let's do B. I have f of x is equal to the negative of the square root of x minus 3. Well, what does that look like? It's a square root function that has been shifted over right and reflected across the x-axis. So it looks something like this. This starts at x is 3, 0. And what is its domain? Domain is x must be greater than or equal to 3. And its range, which is y, is going to be less than or equal to 0. And that's important because we're going to need that information. Now, does it pass my horizontal line test? That was one of the things that we needed to say or check. And sure enough, it does. I don't cross that graph more than once if I have a horizontal line. So I should have, or it does have an inverse function. So I'm going to solve for that inverse function by switching the y's and the x's. So that original equation, that f of x is a y. And so we're going to rewrite this and we're going to switch the x's and the y's. So this now becomes the y, and then I have negative y minus 3, and there's where my x used to be. Now I'm going to algebraically solve for y. I'm going to multiply both sides by -1. I'm going to square both sides to get rid of the radical. And then I'm left with x squared equals y minus 3. I'm going to add 3, and I'm going to just rewrite it so y is on my left-hand side. So I have x squared plus 3. And what do we just find? Well, we analytically found the inverse function of x. So let's write it in correct format. So the inverse function of x is equal to, whoops, not y. It is equal to x squared plus 3. Now, the instructions also told us to find the domain constraints. Well, the domain of my inverse function is the range of my original function. So the domain is x must be less than or equal to 0. All right, let's take a look at see what this looks like graphically. This is a parabola that's been shifted up 3, and so it would look something like that, except that notice that my x values have to be less than or equal to 3. So let's go take a look and see what that might look like. I have to go up 3. So here's my data point, and I'm only going to graph the left side of that parabola because I have to have x values less than 0. Notice if I draw my y equals x line, that is an actual reflection of my original function across that y equals x line. And that is by definition an inverse function. And that data point where it started was at 0, 3. Okay, that graph is not required per the instructions. I just wanted to show you what it would look like. Your turn, won't you try one? Welcome back. Here is what my original function looks like. It's a square root function that has been shifted up 4. Right, okay, so here we'll call that the original point, and it looks something like this. This is at 0, 4 is that data point. The domain of that original function, we'll put off to the right, is x is greater than or equal to 4, and the range y is greater than or equal to, I'm sorry, the domain was x is greater than or equal to 0. The range is y is greater than or equal to 4. I have to evaluate it and say, yep, it meets my horizontal line tests. I am going to replace my x's with y's, my y's with x. So I get x equals the square root of y, a little bit too big of a radical. And then I have plus 4. Now I need to solve for y. So x minus 4 equals the square root of y. I'm going to square both sides. And I will get x minus 4 squared equals y. I want to put it in correct format. What did I just find? I just found the inverse function of x, which is equal to x minus 4 squared. Okay, they asked to provide the domain constraints. So what are the constraints on the original range? Well, y had to be greater than or equal to 4. So therefore, x has to be greater than or equal to 4. What does this look like graphically? Once again, this is a parabola. I'm only going to look at the right side of it because it has to be greater than 4. And it was shifted to the left 4. So 1, 2. I'm sorry, shifted to the right 4. I'm losing it. And I only wanted this half of that parabola. And notice it's a reflection across that y equals x line. This is 0, 4. Didn't have to do that. I'm just showing it to you. The instructions are find the inverse function if it has one and state the domain constraints of the inverse function. All right, let's do another one. Let's graph the original graph. It's a square root function that has been shifted right 3, up 1, and reflected across the y-axis. So I have gone to the right 3, up 1, and reflected across the y-axis. So it starts at 3, 1. And the domain originally was x is less than or equal to 3. The range y is greater than or equal to 1. I'm going to switch my x's and y's. Well, it does have an inverse function. It meets my horizontal line test. I'm going to switch my x's and y's. Negative y minus 3 plus 1. And now I'm going to solve for y. I need to subtract 1 first from both sides. I need to square both sides to get rid of the radical. I need to multiply both sides by negative 1. I need to add 3 to both sides. And I will get my answer, or a function, or an equation for y. And what did we just find? We just found the inverse function of x. So we need to write it in correct format, and that is equal to f of x, or inverse function of x is equal to minus x minus 1 squared plus 3. That's the first step. The other thing they asked for was the domain, which is the range of the original function. And so the domain constraints are x has to be greater than or equal to 1. This is a parabola that's been shifted to the right 1, up 3, and reflected across the x-axis. Right 1, up 3, and reflected, and x is greater than. So I'm only graphing that part of the parabola. And sure enough, it is a reflection across my y equals x line. And that data point that I started at was 1, 3. That part of this example is not required. I'm just showing you what it looks like graphically. This was my answer. Try one yourself. Welcome back. I'm going to graph the original function. It's a square root function that's been shifted left 2 down 6. So we'll call that 2, call that 6. And it's just a square root function, looks something like that. Where am I at? There I am. Okay. Okay, it looks something like this. I'm sorry. Oh, put that back. All right, there it is. Okay, meets the horizontal line test. Need to find my inverse function analytically. I switch my x's and my y's. X equals the square root of y plus 2 minus 6. I need to solve for y. So x plus 6 is equal to the square root of y plus 2. I need to square both sides. And I get x plus 6 squared equals y plus 2. I need to subtract 2 from both sides, and I find y is equal to x plus 6 squared minus 2. And yeah, let's see. Now, next, back to the original graph. This domain, this data point right here was -2, -6. And the domain was x had to be greater than or equal to -2. The range on this, y, had to be greater than or equal to -6. We need that information because we need to evaluate the domain constraints of the inverse function. So we just solved for y on this inverse function. We need to put it in correct syntax. So the inverse function of x, which is what we just found, is x plus 6 squared minus 2. Now the next question was, what are the domain constraints? Well, the domain constraints of my inverse function is the range constraints from my original function. So now my domain, x has to be greater than or equal to -6. So if I wanted to see what that looks like graphically, it is a parabola that's been shifted to the left 6 down 2. So I went all the way over maybe to 3, 4, 5, 6 down 2. So it starts here. But notice I'm only looking at the right hand of the parabola because x has to be greater than -6. So that is a reflection across that y equals x line. Not required per the instructions, just showing you that. Okay. Next one. F of x, x plus 4 squared. Parabola that has been shifted to the left 4. So I'm somewhere right about here. So this is at 0, -4. I'm sorry. That is at -4, 0. Notice that they tell me that the x values are less than or equal to -4. So that original graph is only that portion of the parabola. It meets the horizontal line test. I have to then find my inverse function. I'm going to switch my x's and y's. So x equals y plus 4 squared. I have to take the square root of both sides in order to get rid of that squared. Now, when we take the square root, don't forget we have plus or minus. So I have plus or minus the square root of x equals y plus 4. Don't need those parentheses. Now I need to subtract 4 from both sides. Y equals plus or minus the square root of x minus 4. Okay, let's go back to the original function. What was my domain constraints? X was less than or equal to -4. the range constraint. Y was greater than or equal to 0. Now, in my inverse function, which we have just found to be plus or minus the square root of x minus 4, we have to decide which leg. Is it plus the square root of x or minus the square root of x? Well, how you're going to determine that is by looking at the range. So the range of the inverse function comes from the domain of the original function. So let's go ahead and write that. The range has to be y is less than or equal to -4. And then why not go ahead and put our domain? So x has to be greater than or equal to 0. And we got that from here. Okay. So if my range, my y values has to be less than or equal to -4, because it's less than, I've got to use this negative, because if I pick the positive branch, eventually I'm going to be greater than -4, and I have to be less than, okay? So I'm only going to use the negative branch of that equation. I feel like that's a little bit tricky, but I hope that makes sense. All right, why don't you try one? Welcome back. It's a parabola that's been shifted to the right one, up 4. So we'll call it something. Oh, that's definitely not right one. Right one, up 4. Oh, maybe there. So that is at 1, 4. Notice that it is only the right side of the parabola. X is greater than 1, so it looks something like that. So there is my domain constraint. So I'm just going to go ahead and write that. Domain x is greater than 1. Range y is greater than or equal to 4. It meets my horizontal line test. I then switch my x's and my y's. So I get x equals y minus 1 squared plus 4. I now have to solve for y. X minus 4 equals y minus 1 squared. I take the square root of both sides. I get y minus 1 is equal to plus or minus the square root of x minus 4. I need to add 1 to both sides. So now I get y equals plus or minus the square root of x minus 4 plus 1. All right, let's evaluate my range and domain. So I know that my range, which was my domain before, is equal to y is greater than or equal to 1. I got it from there. My domain is now what used to be my range. So x is greater than or equal to 4. Now, I have to decide before I write my final answer, which portion, the plus or the minus of the square root of x minus 4. Well, if my range is now greater than or equal to 1, then I am going to select the positive portion so that I am always ensuring I'm above 1. So my inverse function of x is equal to the square root of x minus 4 plus 1. I only need the positive portion. They asked for the domain constraints, and so there's my answer. Maybe I should make it a little cleaner. This is my answer, and this is my answer. The only reason why I wrote the range is I needed it in order to figure out which branch of that radical did I need, okay? All right, H. Let's see what this original graph looks like. It is a parabola that's been reflected across the x-axis. It's been shifted left 2, up 4. But I'm only looking at the values of x's that are less than -2. Okay, once again, left 2, up 4, and I'm only looking at the values of x that are less than -2. So this is -2, 4 is my original spot. My domain, my x is less than or equal to -2, and my range, my y, is less than or equal to 4. It's important to write those because you need it. I am going to rewrite this equation, but I'm going to switch my x's and my y's. It does meet the horizontal line test, so I got to find that inverse function. So I have y, whoops, I'm going to put an x equals negative y plus 2 squared plus 4. I'm going to subtract 4. I'm going to multiply both sides by -1, the entire side by -1. I now need to take the square root of both sides, and don't forget that's a plus or minus. So I get plus or minus the square root of the negative x minus 4 equals y plus 2. I now need to subtract 2 from both sides. And I'll go ahead and write it in this format. Negative x minus 4 minus 2. All right. I'm going to write it, well, before I have to decide, do I have a positive square root or a negative square root? How I'm going to determine that is the range. The range is the previous domain. So the domain originally was at less than or equal to -2. So now my range has to be less than or equal to -2. And so I need to use the negative sign. I'm going to rewrite it in correct syntax. Inverse function of x is equal to the negative square root of negative x minus 4 and then minus 2. They asked me to provide my domain constraints. My domain constraints are my original range constraints. So x is less than or equal to 4. This is all that's required for the problem. We could graph it, and it will look something like this: +4, -2, -2, reflected across the x and y axis. It is a reflection across that y equals. It's not perfectly to scale, but that's what it looks like. Let's try one more and we're done. This is a tough one, I agree. Welcome back. What is this graph? It's a parabola that's been reflected across the x-axis, and I'm only looking at the left-hand side because I am looking at values of x less than 3. So it's been shifted to the right 3 and reflected. If I can find my paper. Oh, can't find it. It's okay. To the right 3 and reflected across, the x-axis, and so it's going to go down. What is my domain originally? X is less than or equal to 3. That's original location is 3, 0. And my range is y is less than or equal to 0. Okay, it meets the horizontal line test. I need to switch my x's and my y's. So x equals negative y minus 3 squared. I will then multiply both sides by -1. I will then take the square root, which, don't forget, has plus or minus, and I get plus or minus the square root of negative x equals y minus 3. I need to add 3 to both sides. So y equals plus or minus the square root of negative x plus 3. I now need to determine what leg of that square root do I have, the positive or the negative. Well, what determines that is the range. Well, what the range is used to be the domain. So since I'm less than -3, I'm going to use the negative leg of that. So my inverse function of x is equal to the negative square root of -x plus 3. I was asked to provide the domain constraints. The domain constraints were the original range constraints. So x is less than or equal to 0. What does that graph look like? It's a square root function that has been reflected across the x and y axis and moved up 3. So I have moved up 3. I have reflected it across the x and y axis. So it looks something like that. So, oops, this is at 0, 3 is that point, and sure enough, it is a reflection across y equals x. This is the answer though. All right, that's a tough one. Practice, practice, practice makes perfect.